An electrician encountered a hazardous situation while adding a breaker to a Murray panel. As the cover was being placed back on, a short circuit occurred, tripping a 15-amp breaker. Upon removing the cover, it was discovered that the green grounding wire and the black hot conductor for the Doorbell transformer were connected to the same pigtail leading to the breaker. This resulted in the metal case of the transformer being energized at 120 volts. The Doorbell transformer was likely sitting on its plastic mounting nipple, not making contact with the grounded enclosure. When the electrician moved the cover, the transformer shifted and made contact, causing the short circuit. The improperly connected transformer created a potentially deadly hazard. Had anyone come into contact with its metal case, they could have been electrocuted. The electrician corrected the transformer wiring and emphasized the importance of proper electrical installations. Several important lessons can be learned from this incident. Firstly, always de-energize the circuit before opening an electrical panel. This simple step can prevent accidental contact with live wires and reduce the risk of electric shock. Secondly, ensure that all electrical components are properly grounded. Grounding provides a path for fault current to flow, tripping the breaker and preventing dangerous voltage from appearing on the equipment enclosure. Thirdly, be aware of potential hazards, even when working on seemingly simple tasks. In this case, a seemingly minor task of adding a breaker led to the discovery of a dangerous wiring error. Fourthly, hold individuals accountable for negligent or unsafe electrical work. Improper electrical work can have serious consequences, and it is important to ensure that individuals are properly trained and qualified to perform electrical work. Understanding basic electrical safety principles is crucial for anyone working with or around electrical equipment. Voltage is the electrical potential difference between 2 points, measured in volts. Current is the flow of electrical charge, measured in amps. Resistance is the opposition to the flow of current, measured in ohms. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This relationship is fundamental to understanding electrical circuits. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. Grounding also helps to equalize the potential between different metal parts, reducing the risk of electric shock. Grounding conductors are typically green or bare copper wires. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous ground path. This includes metal conduits, enclosures, and equipment frames. Bonding ensures that all metal parts are at the same potential, reducing the risk of electric shock. The ground fault circuit interrupter, or GFCI, is a safety device that protects against electric shock. It works by monitoring the current flowing in the hot and neutral conductors of a circuit. If there is a difference in current, it indicates that some current is leaking to ground, which could be through a person. The GFCI will quickly trip the circuit, cutting off the power and preventing electric shock. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Circuit breakers are designed to protect electrical circuits from overcurrents. They work by tripping the circuit when the current exceeds a certain level. Circuit breakers are rated in amps, which indicates the amount of current that they can safely carry. It is important to use the correct size circuit breaker for the circuit that it is protecting. Fuses are another type of overcurrent protection device. They work by melting a metal strip when the current exceeds a certain level. Fuses are also rated in amps, and it is important to use the correct size fuse for the circuit that it is protecting. Arc flash is a dangerous electrical hazard that can occur when there is a short circuit or other electrical fault. An arc flash is a sudden release of energy in the form of heat, light, and pressure. It can cause serious burns, blindness, and even death. Arc flash hazards are more common in higher voltage systems, but they can occur in any electrical system. Personal protective equipment, or PPE, is essential for working safely around electrical equipment. PPE includes items such as safety glasses, gloves, and flame-resistant clothing. The type of PPE required will depend on the specific task and the voltage level. Electrical safety training is essential for anyone who works with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and the use of PPE. Regular refresher training is also important to ensure that workers stay up to date on the latest safety procedures. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Working with electricity can be dangerous, but by following safe work practices and using the proper equipment, you can reduce the risk of accidents. Always remember to de-energize circuits before working on them, use PPE, and follow the NEC. Here are some additional tips for electrical safety. Never work on electrical equipment when you are wet or standing in water. Use insulated tools when working on electrical equipment. Inspect electrical cords and plugs for damage before using them. Do not overload electrical circuits. Use extension cords safely. Keep electrical equipment away from flammable materials. If you are not comfortable working on electrical equipment, hire a qualified electrician. When working on electrical panels, be sure to use a voltage tester to verify that the circuit is de-energized. Wear appropriate PPE, including safety glasses and gloves. Use a non-conductive ladder if you need to reach high areas. Work in a well-lit area. Keep your work area clean and free of obstructions. If you are working on a multi-wire branch circuit, be sure to identify and disconnect all of the associated circuits. Be careful when working around energized equipment. Maintain a safe distance. Use barriers to prevent accidental contact. If you see something that looks unsafe, stop work and correct the problem. Report any electrical hazards to your supervisor. Always be aware of your surroundings and take precautions to protect yourself from electrical hazards. This incident highlights the importance of proper electrical work and the potential dangers of unqualified individuals performing electrical installations. The homeowner's reliance on a good friend painter for electrical work resulted in a hazardous situation that could have had serious consequences. It is crucial to emphasize that electrical work should only be performed by qualified and licensed electricians who have the necessary training and experience to ensure safe and compliant installations. Unqualified individuals may lack the knowledge and skills to properly install and maintain electrical systems, leading to dangerous conditions such as improperly grounded equipment, overloaded circuits, and exposed live wires. These conditions can create a significant risk of electric shock, fire, and other hazards. Homeowners should always verify the qualifications and credentials of anyone they hire to perform electrical work. This includes checking for a valid electrical license, insurance, and references. It is also important to ask about the electrician's experience and training in the specific type of work that needs to be done. By hiring a qualified electrician, homeowners can ensure that their electrical systems are installed and maintained safely and in accordance with all applicable codes and regulations. This can help to prevent electrical hazards and protect their family and property from harm. In addition to hiring qualified electricians, homeowners should also take steps to educate themselves about basic electrical safety. This includes learning about the common electrical hazards in the home, such as overloaded circuits, frayed cords, and improperly grounded outlets. Homeowners should also learn how to identify and correct these hazards, as well as how to use electrical equipment safely. There are many resources available to help homeowners learn about electrical safety, including websites, books, and classes. By taking the time to educate themselves, homeowners can make their homes safer for themselves and their families. Finally, it is important to remember that electrical work is not a do-it-yourself project. Unless you are a qualified electrician, you should never attempt to perform electrical work yourself. Electrical work is inherently dangerous, and it is easy to make mistakes that can have serious consequences. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. It is always better to be safe than sorry when it comes to electricity. The NEC provides specific requirements for the installation of doorbell transformers. These requirements are designed to ensure that the transformer is installed safely and that it does not pose a hazard to people or property. Some of the key requirements for doorbell transformer installations include the following. The transformer must be listed and labeled for its intended use. The transformer must be installed in accordance with the manufacturer's instructions. The transformer must be protected from overcurrent. The transformer must be grounded. The transformer must be located in a readily accessible location. The transformer must be installed in a dry location. The wiring to the transformer must be properly sized and protected. The connections to the transformer must be made using approved methods. By following these requirements, you can ensure that your doorbell transformer is installed safely and that it does not pose a hazard. The NEC also addresses the use of flexible cords and cables. Flexible cords and cables are commonly used to connect portable appliances and equipment to electrical outlets. However, they must be used properly to avoid electrical hazards. Some of the key requirements for flexible cords and cables include the following. Flexible cords and cables must be listed and labeled for their intended use. Flexible cords and cables must be used in accordance with the manufacturer's instructions. Flexible cords and cables must be protected from damage. Flexible cords and cables must not be used as a substitute for permanent wiring. Flexible cords and cables must not be run through walls, ceilings, or floors. Flexible cords and cables must not be concealed behind walls or ceilings. Flexible cords and cables must not be used in wet or damp locations unless they are specifically listed for that use. Flexible cords and cables must not be overloaded. By following these requirements, you can ensure that flexible cords and cables are used safely and that they do not pose a hazard. In addition to the NEC, there may be local electrical codes and regulations that apply to electrical installations in your area. It is important to check with your local building department to determine what codes and regulations are in effect. Local codes and regulations may be more restrictive than the NEC, and they may address specific issues that are not covered by the NEC. By complying with all applicable codes and regulations, you can ensure that your electrical installations are safe and compliant. Electrical safety is a shared responsibility. Everyone who works with or around electricity has a responsibility to follow safe work practices and to report any electrical hazards. By working together, we can create a safer electrical environment for everyone. Remember, electricity is a powerful force that can be dangerous if it is not handled properly. Always take precautions to protect yourself from electrical hazards. The incident described underscores the importance of never assuming that electrical work has been done correctly, even if it was performed by someone who claims to be knowledgeable. Always inspect the work yourself, or better yet, have a qualified electrician inspect it before energizing the circuit. This is especially important when dealing with modifications or additions to existing electrical systems. In this case, the homeowner trusted the painter to install the doorbell transformer, assuming that he knew what he was doing. However, the painter's lack of electrical knowledge resulted in a dangerous wiring error that could have had serious consequences. It is always better to be cautious and to verify the work before assuming that it is safe. Another important takeaway from this incident is the importance of de-energizing the circuit before working on it. The electrician in this case admitted to working hot, which is a dangerous practice that should be avoided whenever possible. De-energizing the circuit eliminates the risk of electric shock and allows you to work safely in the electrical system. While it may be tempting to work hot in order to save time, the risk of electric shock is simply not worth it. Always take the time to de-energize the circuit before starting any electrical work. If you are not sure how to de-energize the circuit, consult a qualified electrician. Finally, this incident highlights the importance of proper grounding. Grounding is a critical safety measure that helps to protect against electric shock. When electrical equipment is properly grounded, it provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and de-energize the circuit. In this case, the doorbell transformer was not properly grounded, which allowed the metal case of the transformer to become energized at 120 volts. This created a dangerous situation that could have resulted in electric shock or even death. Always make sure that electrical equipment is properly grounded before using it. If you are not sure how to ground electrical equipment, consult a qualified electrician. The NEC Section 110.3 provides guidance on the examination, identification, installation, and use of equipment. Specifically, 110.3. B states that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. This means that any electrical equipment that is listed by a recognized testing laboratory, such as Underwriters Laboratories or Intertech, must be installed and used according to the manufacturer's instructions. This is important because the listing ensures that the equipment has been tested and found to be safe for its intended use. If the equipment is not installed and used according to the manufacturer's instructions, it may not function properly or it may pose a safety hazard. The NEC Section 250 covers grounding and bonding requirements. Section 250.4 describes the general requirements for grounding and bonding. Section 250.4 A5 states that non-current carrying metal parts of equipment shall be bonded together into the system grounded conductor. This means that all metal parts of electrical equipment that are not intended to carry current must be bonded together to create a continuous ground path. This is important because it helps to prevent electric shock by providing a low resistance path for fault current to flow back to the source. Section 250.24 covers grounding of service-supplied alternating current systems. This section provides detailed requirements for grounding the neutral conductor of the electrical service. The neutral conductor is the conductor that carries the return current from the load back to the source. Grounding the neutral conductor helps to stabilize the voltage and to provide a low resistance path for fault current to flow back to the source. Section 250.50 covers grounding electrode system. This section requires that all grounding electrodes that are present at a building or structure be bonded together to form a grounding electrode system. This helps to ensure that all parts of the electrical system are at the same potential, which reduces the risk of electric shock. Common grounding electrodes include metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings.